Today we are going to learn how to add decimal fractions. But first, we're going to repeat how ordinary fractions are added. So, I'm going to write down the following example. So, 1.2 tenths plus 2.3 decimals. Let's try to add these fractions together. We don't know how decimal fractions add up, but we know that I can write each decimal fraction as an ordinary fraction. So I will write the fraction 1.2 decimals as 1.2 decimals. And I will write the fraction 2.3 tenths as 2 whole 3 tenths. As a result, I will get the addition of two mixed numbers. I will remember the rule on how to add two mixed numbers. To do this, I must add the whole part to the whole part and add the fractional part to the fractional part. And in doing so, pay attention to the denominators. My denominators are the same, so I can add the whole parts of 1 plus 2. And I can add the fractional parts 2 tenths plus 3 tenths. What is the result? I end up with 1 plus 2, which is 3 integers, and 2 tenths plus 3 tenths, which is 5 tenths. The result was the number 3.5. And 3.5, I can write it down as a decimal fraction, which is 3.5 tenths. In this case, it turns out that if I am to 1 point, I'll add 2.3 to 2 tenths, I get 3.5. We've added up these fractions. However, when decimal fractions are added using ordinary fractions, particularly mixed numbers, the algorithm becomes excessively lengthy. This is the exact reason why the process is considerably time-consuming. There is an algorithm for adding decimals. For this, we need to know an important rule. We can count the sum of decimal fractions in a column. So how is it done? Well, to do that, it's important to remember that when we write down, when adding two numbers together, the whole part of each number should be written directly under the corresponding whole part. The same goes for the fractional part, with the decimal point written directly under the other decimal point. For example, if I have written down 1 whole and 2 tenths, I must write down 2 wholes and 3 tenths directly under it so that the whole parts align and the fractional parts align. This means I will be writing 2 integers under 1. I put our dot and then I write down 3 tenths. Now pay attention. It's very important that the dot goes under the point. The whole part stood under the whole part, and the fractional part stood under the fractional part. Now we can add it up. 2 plus 3, that's 5. Write it down. Next we have a dot. We carry it over, and 1 plus 2, that's 3. The outcome is 3.5. Thus, we can add decimal fractions without converting them to a mixed number or to an ordinary fraction, but just using this algorithm. And now we will look at another example when the number of decimals is not equal. So here's the second example. Let's say that I need to add 5.63 hundredths and add 1.2 tenths. What happens in this case? The point is that you and I have already agreed that we will add by column. So I'm writing down the first number, 5 whole 63 hundredths. And now I have to write down 1.2 tenths. We've talked about writing the whole part under the whole part, the point under the point. So I'm going to take this number and I'm going to put it here. It over here. So I write 1 whole part under 5 whole parts, put a dot, and I write 2 tenths under the 6th part. But what's going on here? The thing is, we haven't written any number under the 3. So how do we add up the decimal data? The thing is, let's remember the rule. I have the freedom to put any number of zeros at the end of the decimal point entry without any limitations. And I only need 1 0. Why? Because I don't have any number under the 3. So I write zeros. So I put a 0 in there because 1.2 tenths is the same as 1.20 hundredths. So I add a 0 to 3, that's 3. Adding together 6 and 2 equals 8. A point, 5 plus 1 is 6. The result is a fraction of 6.83 hundredths. I'm going to write down the result of our addition, which is 6.83 hundredths. Guys, let me explain the rule for adding decimal fractions. In our next lesson, we will solve an example using this rule. That's all I have for today. Goodbye, and I hope to see you again soon.